Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss resonance structure. Last class I have discussed inductive effect. Now I am going to discuss resonance structure. There are many organic molecules whose behavior cannot be explained by a single Lewis structure. An example is that of benzene. It's a cyclic structure containing alternate CC single and CC double bond is inadequate for explaining its characteristic properties. Only by benzene structure having single, alternate, single and double bond, this structure is inadequate for explaining its characteristics properties. As per the representation, that is benzene structure, I told you 6-membered ring having alternate, double and single bond. As per the representation between representation of benzene should exhibit two different bond length. Single bond length is different, should be different than double bond length. But in fact, it is not like that. Carbon-carbon single bond and carbon-carbon double bonds are showing, or they are, you can tell, they have a different this bond length. However, as determined experimentally, benzene has a uniform carbon-carbon bond distance, and its bond distance is 139 picometer. Experimentally, its bond length is determined, and it is found 139 picometer, a value intermediate between the carbon-carbon single bond and carbon-carbon double bond. Carbon-carbon single bond is 154 picometer and carbon-carbon double bond is 134 picometer. But average of these two, that is a 139 picometer, actually it is found by experiment. Means intermediate between the carbon-carbon single bond and carbon-carbon double bond. That is between intermediate between 154 and 134 picometer. 154 is carbon-carbon single bond and double bond is 134, and overall in benzene it was found 139 picometer. Thus, the structure of benzene cannot be represented adequately by the one structure. One structure means 6-membered ring only. Further, benzene can be represented equally well by energetically identical structure. Actually, it has two structure. First structure is just both are 6-membered ring, but if you will start with single bond and then double bond. Suppose carbon number 1. Suppose carbon number 1 is a double bond. After that, carbon number 2 single. Like that again double, single, again double. Then this is the one structure. Carbon number 1, between carbon number 1 and 2, it is a double bond. After that single, again double, again single, again double. Like that. And second structure, That is, now carbon number 1 will come single structure. You can start with single. After that double, again single, again double. Okay. Then there are two structure. There are two possible structure. Means carbon number, first structure carbon number 1 and 2 was having double bond, and in second structure carbon number 1 and carbon number 2 has a single structure. Then if carbon number 1 starts with double, then after that single, double, single, double, alternate double and single bond. And in structure number 2, carbon number 1 and 2, single structure is there. The next will be double, again single, again double, again single, like that way. Then that it can be represented by two structure, but both structures are not characteristics or are not telling, you can say, all properties of benzene. Okay, one equivalent structure is there. One equivalent structure is there. In that structure, carbon number six membered rings are there, but in the middle one you can say circle is there. One circle is there, that telling that double is becoming single, single is becoming double. Electrons are moving. Then this structure, this equivalent structure, that is also called a resonance structure. This equivalent structure, third structure, is equivalent that inside the benzene ring one circle will be there. That represent, actually that explains, that structure explains all properties of benzene. Therefore, according to resonance theory, the actual structure of benzene cannot be adequately represented by any of the structure, means structure 1 and structure 2. Rather, it is a hybrid of two structure, first and second structure, hybrid structure. That is the third equivalent structure, that is called hybrid of first and second. That is called resonance. First called resonance structures. Okay. First two structures I told you. Then any of these structure can't explain the all properties of benzene. Rather, it is a hybrid of the two structure called resonance structure. Third structure is called, which is equivalent to these two structures, is called resonance structure. That structure tells full property or explains full properties of the benzene. The resonance structures or contributing structures are hypothetical and individually do not represent any real molecule. Actually, this canonical structure, two structure, structure 1 and structure 2, also called resonating structure, they are actually hypothetical, and anyone actually do not represent any real molecule. They contribute to the actual structure in proportion to their stability. Okay, each one will tell some properties not full. Another example of resonance is provided by nitrobenzene CH3NO2, which can be represented by two Lewis structure, structure 1 and structure 2. What are that structure? I am telling you now. CH3NO2, then CH3NO2, then NO2 that have two oxygen. Then one oxygen has double bond and other oxygen has a single bond. In NO2, one oxygen has a double bond, other oxygen is a single bond, and N is a positive charge, means its lone pair of electron is taken by any one oxygen and made double bond. That's why in NO2 one is a double bond and other is single bond, and N has a one plus sign because lone pair electron is taken by neighboring oxygen. Then now here other structure is structure 1, and other structure is that where double bond was there, now it became single bond and other oxygen has double bond. Just reverse of first one. First one, double bond was there and one single bond with oxygen. With both oxygen, one oxygen had a double bond, other single bond. But now in second structure, which was having double bond, now it has single bond, and which was having single bond, now it has double bond. That is the means it happened due to the movement of electron. You know that oxygen which have double bond has 2 lone pair of electron, and oxygen which has single bond has 3 lone pair of electron. Then this which is a single bond and having 3 lone pair of electron, that can make double bond. This single bond was there. When they will donate this 2 electron, then single bond will become double bond, and double bond which was the double bond, you can say electron, that double bond will become single bond, and that electron will be taken by that oxygen only. In the beginning, what was the oxygen was having double bond, that will become single bond, and that electron will be taken by oxygen, that oxygen only, because of electronegativity. And which was the first electron only on single bond and having three lone pair of electron, then one electron pair they will give and single will become double, means just reverse of the second structure is reverse of the first structure, means double bond, where it was double bond that became single, and where it was single that became double. Then these two structures are called resonance, and both structure will not explain all properties of methyl, nitromethyl. It will not tell all properties of all nitromethyl. Then one equivalent structure will call that is a hybrid structure. Hybrid of these first and second, third structure, equivalent structure of both. And that structure, what is these things here? Here neither this double and single. In one structure, double and single bond was there, and the first structure, double and single. Now in second structure, single and double. Then now third structure will show that equivalent structure, means now just one half circle will come. It will not double and single bond in third structure, double and single bond it will not show. Only one dot structure, half, from starting from one oxygen to the other oxygen via nitrogen, that dot just like a half circle structure will come, means no single bond, no double bond. One you can say dot structure will be there, just like half. In the middle nitrogen is there, same structure, only double single bond is not there, only one bond is there, and for the second bond or dot will come. This is the third structure, hybrid structure. That is called hybrid of the two structure. That's also called resonance. This first and second structure, that is called resonance structure, and hybrid is the equivalent structure, and its energy will be less than these two. What they have little more energy, but this third structure, equivalent structure, their energy is less in comparison to the first and second, and due to that, because it has a less energy, hence hybrid structure is more stable. And what is the difference between the energy between the canonical, resonance structure is also called canonical structure. Then energy difference between the hybrid structure and canonical structure, that is called resonance energy. Energy difference is called resonance energy, and due to that, if difference is more, this energy difference is more, means this equivalent, means hybrid structure is more stable because it has any stability. As the energy will be less, molecule will be more stable. Then third structure, hybrid structure is less, that's why it is more stable. Then this, how much stability in comparison to this resonating structure, canonical structure and hybrid, what is the difference in stability? Then that depends upon the difference of energy. More the difference of energy, more the stability. Okay, and this difference of energy is called resonance energy. I will try to send the structure. However, it is known that the 2NO bond of nitromethane, in nitromethane 2 bond is there. I told you, one single, another NO and N-double-O bond. It is known that 2 NO bonds of nitromethane are of the same length. Why it is the same length? Already I have told you. Because the third structure, actually it exists, that nitromethane exists in the third form, hybrid, and its bond length will be almost equal only. And its bond length is intermediate between NO single bond and NO double bond, just like benzene. The actual structure of nitromethane is therefore a resonance hybrid of the two canonical structure, two canonical forms, first and second. Two canonical forms, first and second. Third one is the resonance hybrid. Okay, in that both NO bond will be equal or intermediate, we can tell. The energy of actual structure of the molecule, that is called this actual structure of the molecule, means a resonance hybrid, is lower than that of any of the canonical structure. The difference in energy between the actual structure and the lowest energy resonance structure is called the resonance stabilization energy. Question is asked, what is the resonance stabilization energy? Then the difference of, listen carefully, the difference of energy between the actual structure and the lowest energy resonance structure. Difference between difference in energy between the actual structure, means hybrid, and the lowest energy resonance structure is called the resonance stabilization energy, means energy between the actual and resonance structure, that is called stabilization energy. or also we can tell resonance energy, resonance stabilization or resonance energy. The more the number of important contributing structure, the more is the resonance energy. Means of now here is 2, sometimes it will be 3. Then as the number of resonating or canonical structure will be there, more the canonical structure or canonical structure or resonating structure, more the stability. The more the number of important contributing structure, the more is the resonance energy. Resonance is the particularly important when contributing structures are equivalent in energy. Actually, these canonical structures, they will not differ too much in energy. They will differ, but not too much. Then finally it will tell that is the hybrid of these structure, that will be the final, that will be the very less than these two, and then difference of energy is called resonance stabilization energy or simply resonance energy. Now again I am telling you, resonance is particularly important when the contributing structure, means resonating structure or canonical structure, are equivalent in energy. The following rules are applied while writing the resonance structure. I am telling you rule. These rules are important while writing the resonance structure. What are the rule? Now you listen. The resonance structure have, first rule, the same position of nuclei. Resonance structures, means canonical structure, they will have, first thing I am telling you, they will have the same position of nuclei, first thing, and second, same number of unpaired electrons, same nuclei and same number of unpaired electrons. These are the two important things. Among the resonance structures, the one which has a more number of covalent bonds, all the atoms with octet of electron except hydrogen, which has a doublet, less separation of opposite charges, means a negative charge, if any, on more electronegative atom, a positive charge if any one more electropositive atom, and more dispersed and more dispersal of charge is more stable than others. Now listen again, and I will explain also. See, among the resonance structure, the one which has more number of equivalent bonds, equivalent bond means covalent bonds. Among the resonance structure, the structure which has a more number of covalent bonds, all the atoms with octet of electrons, less separation of opposite charges. There will be less separation of opposite charges. If any, I am telling you, if any one not on, if any on more electronegative atom, if any on a more electronegative atom, a positive charge, there will be a positive charge. If any on more electropositive atom are more dispersed. Here again you listen that among the resonance structure, maybe 2, 3, the one which has more number of covalent bonds, then what will happen? All the atoms with octet of electrons, means which have 8 electrons, exception is hydrogen, 8 electrons, less separation of opposite charges. They will have less separation of opposite charges. Means it will be a negative charge. A negative charge, if any on more electronegative atom, and will be a positive charge if any on more electropositive atom, and more dispersal of charge is more stable than others. Means if charge is more dispersed, first you can tell that separation of charge will be less. In simple way, positive covalent bond is there, all are covalent bond, then that charge separation will be less. First thing, sir. And if charge dispersal is more, means it is distributed more. Charge distribution means sometimes you will see the structure, double will become single, single become double. Suppose it is a straight line, 5 carbons are there, one is a double bond, other is single, double, single. Then like that way, during the movement, double will become single, single will become double, pi electron will move. Means that is called when electron will go from the first carbon to the second carbon. Then first carbon will get positive charge, and where electron is moving, there it will be negative. Again that negative, and again you can say suppose it is making double bond there, then again same thing will happen. That electron will go to the other carbon atom. Then again second will be positive and third will be negative. Again third can make the bond. Then that electron again it will move. Then again it will get positive, and where it will move, there will be negative. You know, the simple things. Wherever electron density will be more, at the direct direction in which electron is moving, that direction it will be negative, and backside it will be positive. From where it is going, that will come positive. Where electron is going, that atom will be negative. And more, if charge separation is more, dispersion is more, because suppose sometimes maybe only two carbon, sometimes 3 carbon, sometimes 4 carbon chain, 5 carbon chain. Then when charge separation will be more, means positive is becoming negative, negative is becoming positive, positive is becoming negative, like that, then more dispersal of charge is more stable than others. In any structure, if charge dispersal is more, then that structure will be more stable. Okay, this I have told you. Now this one example I can tell you. Actually this is the question is asked. I am telling you now, that is a problem. 4 problems are there. I will tell one by one. First problem is that write resonance structure of carboxylate ion, acetate ion, not carboxylate, CH3 COO minus. That is the acetate ion is there, anion, negative charge is there. CH3 COO 1 negative, and show the movement of electrons by curved arrow. Curved arrow you have to apply. By the use of curved arrow you can show the movement of electron. Then now this is the very easy to write the structure. Okay. Here what will happen, that you have to write resonance structure of structures of CH3 COO 1 minus is there. You have to write. Very easy. CH3 first to write, methyl group, one bound. After that carbon you have written. With carbon, this carbon, 2 oxygen is attached. One is a double bond, other is single bond. Correct? This is the structure 1. And structure 2, that again CH3 you have to write, one bond with carbon, and now again 2 oxygen is there. Then now this time where double bond was there you write single bond, and where single bond was there you write double bond. Because in the first structure you have written one oxygen was having double bond, other was having single bond. But now other structure, second structure, what will happen? It will be the reverse, where it was the double bond with oxygen, carbon oxygen double bond, that will come carbon oxygen single bond. And where carbon oxygen single bond was there it will be double bond. Now how will you show the movement by the curve? Curved arrows, how will you show? By use of curved arrow. Then very easy, where double bond is there, first structure, carbon oxygen double bond is there. Then just to write a curved structure starting from the middle of the double bond, and arrow should be on oxygen atom, means starting from the double bond, middle of the double bond, tail will be on the middle of the double bond, and head will be, means arrow will be on oxygen. Then in second structure, means this structure is showing a arrow structure, that electron will go to the oxygen atom. Now it is a double bond. But in next structure, now this electron, pi bond electron was there, 2 electron was involved. Thus 2 electron will be taken by oxygen, and double bond will become single bond. Hence in next structure you will write single bond, and on oxygen 3 pair of electron. Already in the first structure oxygen was having 2 pair, now it became 3 pair. And these things, second, now we have seen in the first structure it was double bond, and in second structure it became single bond, and arrow sign was on towards oxygen atom, because electron was going on oxygen. Then 2 pair, now it became 3 pair. Correct? And again you can see other oxygen situation, then which was having single bond in the first structure. Then there that oxygen was having a triple, I can say 3 lone pair of electron. Second oxygen was having 3 lone pair of electron. Now that with the arrow sign you can see that 1 pair of electron, means tail will be near the 1 pair of electron, and head will be, means arrow will be towards middle of the single bond. It means this double bond is going towards a single bond, and it will make double bond. That's why in second structure now, where in the first structure it was a single bond, now in second structure it will become double bond. Correct? This is the you can say movement of electron, and between the two structure you have to write one arrow, one line, and this just like a reversible reaction, means from the first structure it will go to the second structure, and it will from the second structure you can it can come to the first structure, from first to second, second to first, just like a reversible reaction. And that you can show by one line you draw, and both end you put arrow. Both end you put arrow, means from structure 1 to structure 2, and from structure 2 to structure 1, both end will have one arrow. Okay, then like that way you can show both structure. Then you have written that structure 1 is converting to a structure 2. You have shown by arrow sign, curved arrow sign you have seen. Now if suppose second structure wants to become first structure second, now suppose it wants to come first, because both are resonating, then how will you can say show the this arrow when second will become first structure? If second becomes first structure, then that time how arrow sign you will apply? Curved arrow, how will you apply? Then again very simple things, because which was the second, what was the you can say in the double bond in the first structure, second become single, double become single in second structure. Then now you want to bring first structure, then again same things. Now oxygen has a 3 lone pair of electron, then now tail will be near the distance one pair of oxygen, one pair of electron, and arrow will come in the middle of a single bond. Curved arrow will be in the middle of single bond, means it is showing this double bond which is near the tail, that is coming to the single bond. It will make double bond. Then bond will be only one, only arrow sign you can say that now double bond will come. That arrow will show that it will come. Then starting from this tail will be near the electron, one pair of electron, and head will be near the middle of the bond. It means that now double bond will come to the single bond and it will make double bond. Then now it will become like the structure 1. Now this single bond is becoming double bond, and other again same way structure 2 where double bond was there, that has to become single bond. Then again same way you have to start a tail will be in the middle of the double bond of structure 2. In structure 2 it is double bond. One has a single bond, already told you, and other double bond, from there tail will be there in the middle, and head will be near the oxygen atom. It means arrow will be on the oxygen atom. It means that double bond now it is going to break, and both electron will be taken by oxygen. Then now completely second structure will become first structure. First structure was one double bond. First was the double bond, oxygen, and second oxygen was single. Now same things you will get. Then this is the by arrow sign you can show it. I will try to send is this type of movement. Already I have sent the last class how electrons are moving. Same things are here. Now second question is there. Write resonance structure of CH2 double bond CH and CHO, aldehyde group is attached. Aldehyde CHO group is attached with ethylene CH2 double bond CH and one CHO is attached. Then you have to write the resonance structure of this CH3 double bond CH and CHO is attached. Indicate the relative stability of the contributing structures. Which are the more stable structure that you have to write. Then now you can write very easily. CH3 is there. You write CH3 double bond is already there. And CH is there. And again third CHO, that C is there. Then third carbon is C. And after that, with that C, double bond oxygen is attached. CHO structure already told you. In CHO, O has double bond. It is attached with carbon. And one hydrogen is there. Then now structure 1 is CH3 double bond CH. Again single bond C. And oxygen is attached double bond having 2 lone pair of electron. And after that, last carbon is attached with hydrogen. This is the first structure. Now again you can see that second structure, how will you write? Then here movement will start. Electron movement will start. CH and C single bond was there in the structure 1. Now that will become double. Okay, CO was double bond, then that bond will become single, and that electron released from the double bond that will be taken by this nearing adjacent carbon will take, and single bond will become double bond, and oxygen which was having C and O double bond, that will become single bond. Then now there this CH and C in second structure, now it became double bond. Okay, this is the second structure, and C and O will become single bond. Okay, double bond become single bond. One thing to always keep in mind, whenever oxygen is making single bond with carbon, there that time 3 lone pair of electron will be there. And now third, and one more things I am telling you here, actually that C and double O, structure 1 double bond was there, C and O. Then there actually what happened there, this oxygen is electron negative atom. Hence that electron will be taken by oxygen, and carbon was contributing one electron, oxygen was 1, and carbon was 1, because this pi bond was there. Then now that when bond will break, then one electron will be taken by oxygen and one electron will be taken by carbon. Then now carbon has 1 electron. Then by the 1 electron bond will be not formed. Here it is making double bond. Then from where 1 electron will come? This is the question. Then now I told you first and second carbon was double bond according to the question. Already it was double bond, CH to CH, double bond was there. Then now what will happen? This bond will break. And that electron both can say this both electron will be taken by that C and will give to there to make a double bond, because that time electron was taken by, or you can tell that this first and second bond was there and double bond. One bond is breaking, then electron, one electron, both carbon will take. Then now first carbon, actually really in this case that carbon will this two carbon will come to this side to make a double bond, and C and O, that bond two electron, that electron will be taken by oxygen. Then that time become one bond, single bond, and now this actually double bond will become single bond, and where single was there it will go double bond, means the second and third it will become double bond, pi bond movement. Double became single and single became double, and C and O, it was double bond, that will become single bond. Okay, this structure it became like that. Then CS, first carbon, because they lost the electron, that's why it will become positive, and oxygen is already negative. Okay, then this is the structure second. Now structure second become CH2, C will have 1 plus, and C, and next with bond adjacent carbon bond will be single bond, and second and third will become double bond, and carbon and oxygen will become single bond. This is the structure second. And structure third, one more structure is there. All are interconvertible. And third structure, now what will happen, that this oxygen, what it will do now, oxygen was having a three lone pair, oxygen was having. Then now what will happen here, that it will give one pair of electron, and this one pair of electron will be given to first carbon. Actually here rearrangement will take place, then because first carbon has lost all to a structure in making the second structure, then they were having plus charge means one pair of electron it lost. Then what will happen, now that electron, one pair of electron of oxygen will be given to that carbon. Then now it will have negative charge. Okay, that electron means a rearrangement of electron took place to make a stability, and that's why that carbon will now have because they have taken one pair of electron from oxygen, that's why it will become this thing negative. Then three structure you got, then which out of three, which one is more stable? Then first structure is more stable than second structure, and second structure is more stable than third structure. Okay, then structure 1 is most stable. Why? Because more number of covalent bonds. Each carbon and oxygen atom has an octet and no separation of opposite charges. Okay, structure second, negative charge on a more electronegative atom, and a positive charge on more electropositive atom. And third does not contribute as oxygen has positive charge, that's why no contribution. Third, that does not contribute as oxygen has positive charge and carbon has negative charge, hence least stable. Then this I have told you about this problem. This type of question is asked. Oxygen should not have positive charge. If it will donate, then it will be not stable. Structure will be not stable. That's why third structure is least, because oxygen has a positive charge. And structure 1 was most stable. Why it was more stable? Because more number of covalent bonds was there, and each carbon and oxygen atom has an octet. Octet means stable, and no separation of opposite charge. There was no opposite charge at all in the structure 1. That's why most stable. But here second structure, charge was there. Charge was there. Negative charge and positive charge both were there. Negative charge on more electronegative atom. In second structure, oxygen was having more negative and carbon was having one positive, first carbon. Then negative charge on more electronegative atom and positive charge on more electropositive atom. That's why it is coming, it is less stable than the first one. And third one I told you, does not contribute as oxygen has a more positive charge. Or you can tell oxygen has positive charge and carbon has negative charge, hence big opposite. That's why this will be least stable. one more this is their problem, I will tell you. Explain why the following two structures, first and second, cannot be major contributor to the real structure of this thing, CH3 COO CH3 CH3 COO CH3. This structure is there. Means first and the last CH3 is there. And in the middle, this middle carbon, 2 oxygen is attached. Total 3 carbons are there. Then first carbon is attached with CH3. And this OCH3 group is attached with the carbon, second carbon. Means left and right, one side CH3 is there, middle carbon I am talking about, with one carbon, left side CH3 is there, and right side OCH3 is attached. And that middle carbon's CO is there, CO, single bond is there. Means both oxygen is a single bond. Then now you have to ask why the following two structure, first and second, cannot be major contributor to the real structure of CH3 COO CH3. Then now here you can see the first structure I told you, second structure that is also can be there, CH3. Now this one carbon is attached with now single bond with oxygen, and other oxygen has double bond, but it has positive charge. Oxygen, because they made single bond, then that is a positive charge, and already CH3 was attached with oxygen, and so structure is same, only charge difference is there. It is just like first structure only in the first structure no charge was there, but in second structure oxygen second oxygen has double bond and O positive charge, charge development is there, all things are same. Then here you see the two structures are less important contributors. Why? Because they involve charge separation. They involve charge separation. A positive charge is there, charge separation, as they involve charge separation. Additionally, again another point, additionally, structure 1 contains a carbon atom with an incomplete octet. That second carbon, first structure, that carbon has not, you can say, complete octet. Complete octet is not there. Then complete octet is not there, hence this structure is also not stable and it will not contribute. Then first structure, octet is not contribute, and in second structure, charge separation is there. That's why both will not, you can say, contribute this due to these two reasons. Okay, they will not contribute, they will not be the major contributors to the real structure of CH3 COO CH3. Okay, this I have told you, and now I am stopping only here. Next class I will discuss resonance effect. Today I have discussed only resonance structure. Next class I will discuss resonance effect, electromeric effect, and hyperconjugation. 3 effects I will discuss. Thank you.